So anyway, there's been a lot of good work being done on the San Joaquin restoration project. We're going to hear some more about it from Amy Krish. She works in our Fresno Fish and Game office, Fish and Wildlife office, and she had a very important conference call about the what's it called, the super rail or the high-speed rail project. In fact, I was talking to her about it before when she asked me to change her presentation around so she could take this conference call. And I didn't even realize that corridor is going to be all fenced. And so it's going to be like cutting the Central Valley in half. I didn't even think about that. So she's on the team at Fish and Game to try to deal with those situations of migratory routes and stuff. So that's kind of interesting. But she's going to be talking about restoration of the San Joaquin River right now.
Thanks, Jim. And like he said, I am the liaison to the high-speed rail project. My point being, I'm not a part of the San Joaquin River Restoration Program officially in Fresno. But when I did take that position, I had a momentary lapse of judgment and thought it'd be a great idea to go back and get my master's degree at Fresno State. So that's what I did. And part of the great thing about our office in Fresno is that you can kind of rub elbows with some of the other programs and get in on their field work and kind of do some of the more fun stuff that they do rather than permitting, which is what I do behind a desk all day. So I sort of weaseled my way into the San Joaquin River Restoration Program and helped out with their data collection, and it didn't seem like there was a lot being done with the data, so I decided to use it for my master's thesis. And now that I've told you my whole life story, I just want to point out that I'm, again, not a part of the program, so I'm going to do the best I can to explain it and answer questions. I'm definitely not a statistician. You can probably rip my statistics apart, so please be kind, and hopefully that lowered your expectations a lot. So with that, I'm going to be talking about Chinook salmon. Their scientific name, the best way I can pronounce it, is Oncorhynchus shawitcha. If anybody has a better pronunciation, I'd love to hear it. They are an anadromous species, which means they will migrate from the ocean to freshwater in order to spawn. And those migrations are referred to as runs. And in California Central Valley, there are 4 runs. There's a fall and late fall run, there's a winter run, and a spring run. The fall and late fall run under the Federal Endangered Species Act, as well as the California Endangered Species Act, is a species of concern. The winter is endangered, and the spring is threatened. So once those adults start their migration upstream in the San Joaquin River, they will come up through the San Francisco Bay Delta into the San Joaquin River. They will hold in pools over the summertime. They start, for spring run, they start their migration during the winter or the spring. They'll hold in pools over the summer, and then the females will lay their eggs in what is called a redd or a nest. We had a little bit of a primer on that yesterday. Once the eggs hatch, the fish are known as elven, and they have an embryo sac still attached to them for their nourishment. And then once they emerge from that redd, they're known as fry. And then eventually the fry will develop vertical bars, and they're known as par. So the fry and the par are the freshwater life stages. In the Central Valley, the spring run fry is the stage at which they begin their migration back to the ocean. So it's almost immediately once they emerge from the redd. They'll undergo morphological, physiological, and behavioral changes to become smolts. And they'll kind of hang out in the San Francisco Bay Delta for a while and get bigger, and eventually go back out to the ocean until they mature and do it all over again. And then most of you probably know, but once the adults lay their eggs, they die in freshwater. So I am focusing on the freshwater life stages, specifically the redd, the fry, and the par. So throughout their life cycle, they require a lot of different habitats. One of them being cobble and gravel in beds for the females to lay their eggs and for the elven to develop. Riparian vegetation and in-stream woody debris will provide cover and predator avoidance for fry and par, and the shade also prevents elevated water temperatures, which also prevents a reduction in dissolved oxygen from exposure of water to the surface light. And they need pools. Like I mentioned before, the adults will hold in pools during their migration before they spawn, and juveniles will also use those pools for resting. And then one of the major important parts of their habitat type is the presence of benthic macroinvertebrates, such as this family. They're a really important food source for fry and parr. And as we all know, they are indicators of freshwater habitat conditions. The better the habitat condition, the more bugs there are, and the higher the diversity of bugs. And so one of the also, last but not least, important parts of their habitat is they need waterways that are unimpeded. And an example of an impediment would be the Friant Dam, shown there. And the Friant Dam was built in 1940, but before its completion, there was historically an abundant population of Chinook on the San Joaquin River. They're mostly non-existent today between the Hills Ferry Barrier, which is at the confluence of the San Joaquin River and the Merced River, and Friant Dam. And I say mostly non-existent because there are some experimental populations that they have in the river currently. And so that decline in population has been attributed to degraded habitat. Operation of the dam caused there to be over 60 miles of insufficient flows. So that also did not help their cause. And in fact, insufficient flows below a dam is a violation of Fish and Game Code Section 5937. So in 1990, there were several agencies that got together to sue the operators of the dam. And in 2009, after 18 years of litigation, the Restoration Settlement Act was reached. And pursuant to that, the San Joaquin River Restoration Program was formed. And it is a multi-agency program. Department of Fish and Wildlife is one of those agencies, Department of Water Resources, Bureau of Reclamation, and a host of other federal agencies are part of that program as well. But they were tasked with two goals. One of them is to increase the flow releases from Friant Dam. Currently, they have interim flows, and by January of 2014, they will be up to full restoration flows. And I believe right now they have released their environmental impact report. It's in their 90-day comment period, and that's kind of what that addresses, is those increased flows. And their second task is to reintroduce spring run Chinook salmon. So before the reintroduction of the salmon, they did a bioassessment of the habitat conditions in 2010, 2011, and 2012. And as you can probably guess, they used the Surface Water Ambient Monitoring Program's bioassessment protocol. So here is the San Joaquin River Restoration Program area. It's not the entire length of the San Joaquin River, which is a 366-mile waterway that originates at about 10,000 feet in the Sierra Nevada and drains a watershed of approximately 13,530 square miles. And throughout that, it's predominantly agricultural land on either side. So this is how the San Joaquin River Restoration Program has divided up their restoration area. It begins at Friant Dam at Reach 1, and it's 39 miles in length, and it goes to Gravelly Ford. And then Reach 2 is Gravelly Ford to Mendota Dam. Reach 3 is Mendota Dam to Sac Dam. Reach 4 is Sac Dam to Eastside Bypass. And then the fifth reach is from the Eastside Bypass to its confluence at the Merced River. And you'll notice, if you can even tell on this map, there are subdivisions of those, but for my purposes, I just used the major divisions. So Reach 1, 2, 3, 4, and 5. And altogether, that's about 150 miles for the restoration area. Now, we're talking a little bit after the last talk about reference sites, and that was kind of one of my issues for my thesis, is I didn't really have a reference site. So I used San Joaquin River Reach 1 as my reference site, and my basis for using that was that after the 2010 bioassessment, there was a preliminary analysis done, and it was found that it was the only reach with sites with good biological condition, and that was also based on the Central Valley Index of Biotic Integrity. It's also the reach that has minimally disturbed conditions. The land on either side is owned by the Department of Fish and Wildlife as part of their San Joaquin River Ecological Reserve or the San Joaquin River Conservancy. So it was kind of the lesser of all evils So with my reference site picked out, I had my research objectives, and that was to use 2010 and 2011 bioassessment data. The 2012 results have yet to be released for external use, so I had to leave those out. And the first question I wanted to look at was the abundance and diversity of benthic macroinvertebrates. And I wanted to compare the remainder of the reaches 2 through 5, to reference site reach 1, and determine which of those reaches restoration should be focused on, rather than just going out there and starting at any old place. The second part of my question was to, again, look at the 2010 and 2011 bioassessment and figure out which habitat variables should be focused on for restoration. And so the methods, obviously, we don't have to go over those. Those are the swamp bioassessment. We did our bioassessment between May and September of each summer, and that was for consistency, and it was also the time during which there were wadeable summer base flows that were around 350 cubic feet per second, and those were intended to provide continuous flow from Bryant Dam to the Merced River and to achieve appropriate water temperatures for spring run Chinook salmon in Reach 1. And then our bioassessment points, we chose 30 out of 150 random GPS coordinates that were generated from the US EPA's Environmental Monitoring and Assessment Program. And those points, again, were chosen because of the bioassessment protocol based on wadeability and accessibility. Accessibility was a big deal. You'd be surprised, well, you probably wouldn't be surprised at how many farmers out there don't want fish and wildlife on their land accessing the San Joaquin River. So that posed a problem, which you will see here shortly. So first I'm going to go over the results of the bugs. These are two examples of some of the species that were found in the San Joaquin River. I got these pictures from somewhere else. They're not mine, so sorry I didn't give credit where credit was due. So here's a little bit of a sample, how many samples of bugs were collected each year and for each reach. One thing to note is the small sample size for Reach 4 in 2010 and the small sample size in 2011 in Reach 5. Again, it was based on wadeability and accessibility, so there's some statistical analysis later on. You'll see the box and whisker plot is kind of shrunken down because there's not very many samples from there. And I mentioned before that there were 30 sites sampled, but in 2010 there were 4 that we double sampled, and there were 3 sites in 2011 as well. So that's why there's more of those. And again, just some summary statistics. You can see the total number, minimum, max, kind of boring. And again, just to remind you, the first research objective I was looking at, I wanted to look at first the abundance, and again, compare reaches 2 through 5 with Reach 1 to determine where restoration efforts should be focused. So with that, I did a one-way analysis of variance, and this is the results from 2010. The results weren't normal, so there's the natural log of the number of benthic macroinvertebrates. At a 95% confidence interval, it was significant. So one of my reaches 2 through 5 was different than Reach 1, and in order to determine which reach that was, I ran a Dunnett's test, and that revealed that Reach 5 was the reach that was different. So again, summary of Dunnett's test. In 2010, Reach 5 was different from Reach 1. Reach 2, 3, and 4 were similar to Reach 1. And then again, for 2011, at a 95% confidence interval, it was significant. And this time, reaches 2 and 5 were the ones that were different from my reference site. So reach 2 and 5 were different from 1 in 2011, and reach 3 and 4 were similar. And this handy map, again, to show you just where Reach 2 and 5 are. Reach 2 is from Gravelly Ford to Mendota Dam, and Reach 5 from the East Side Bypass to the Merced River. And these are actually 2 of the shorter reaches at 24 miles and 18 miles, respectively. So that answered my question, which reaches should be restored? Reach 2 which is historically dry most of the year. Those are some photographs from the summer where they're supposed to have base flows that extend all the way from Friant Dam to the Merced River. There's not a whole lot of water, but I guess that counts. There's sandy substrate, obviously, and limited water conveyance. So the unstable sand and the extreme flow variability obviously will not support high benthic macroinvertebrate populations. And then for Reach 5, that is also one that should be restored first. It receives flows from adjacent waterways that are predominantly banked on either side by agricultural areas, and that lends to poor water quality, and non-point source pollution from ag in the form of sedimentation and pesticides limits BMIs as well. So I saw this data and I thought, well, Reach 2, it's only 24 miles, and then Reach 5 is only 18 miles. Can't the fish just swim really fast through there and they'll be just fine? But their migration rates are very variable. They can migrate as few as 1.4 miles or as many as 19.8 miles traversed in a day. So more than likely, they will be unsuccessful at meeting their energy demands if they get stuck in these areas as they're migrating out to the ocean. So my second part of the first question was looking at the diversity of Reaches 2 through 5 and comparing those to Reach 1. And for that, I used Simpson's Index of Diversity. There's the fun equation and what that means. So it ranges from 0 to 1. The higher the index means the higher the diversity. And this index of diversity I chose because it measures the degree of concentration when individuals are classified into types. So again, I ran a one-way analysis of variance. This is the results for 2010. The results weren't normal, so they were natural log transformed. And it ended up being significant, and Dunnett's test revealed that Reach 4 was different than Reach 1. And again, in 2011, it was significant, and Reach 4 was different than 2001. But you'll notice that in both of those years, Reach 4 had a higher diversity than Reach 1. So we all know that biodiversity is an overall measure of ecosystem health, but because the reaches were higher, and my literature review revealed that when there's restoration projects done to increase the diversity of the bugs, it doesn't really differ a whole lot when compared to non-restored waterways. So I didn't really investigate that further. And we think that Reach 4 had a higher diversity because it's the area that goes through the Los Banos wildlife area. So again, some of it's ag, but a lot of it is protected land. So we think that had something to do with it, but we're not sure 100%. That's just my interpretation. So for the PHAB data, I did a principal component analysis. And again, I'm not a statistician, so you probably rip this apart. But what this helped me determine was where the similarities and differences were. Only principal components with an eigenvalue greater than 1 were retained for interpretation. They explained, the significant ones explained 72.6% of the variance. The first PC explained 20.4%, and the second one explained 15.6%, and the rest were pretty insignificant, so I did not consider those. And then the loading values, I arbitrarily assigned those as either high, moderate, or low, and the ones that are highlighted are quote-unquote high. Those are greater than 0.30, and that loading value represents the amount of influence that that variable had in constructing that principal component. So when I looked at this, I saw that on principal component 1, it looked like it was more had to do with the complexity of the environment, and principal component 2 had a lot to do with egg and red success. So I concluded from that for most of the restoration projects that I read in my literature review, just had some typical, adding boulders, woody debris, artificial structures, and riparian canopy vegetation to increase the habitat complexity. And kind of the elephant in the room would be the fact that along that 150 miles in the restoration area, there are a lot of impediments. And that's part of what the restoration program does, is they're working to either remove the dams completely or put fish ladders that are more friendly for salmon migration. So that's one thing that they're working on that I think the EIR addresses as well. And then for the reds, that can be improved by adding gravel and altering the stream bed topography with boulders, woody debris, and artificial structures as well. And the depth and water velocity are really important factors for red site selection for spawning females. And they often select sites in areas of transition between a pool and a riffle where the topography will induce flow through the substrate. So they'll favor areas where there's logs, debris dams, and large channel features such as gravel bars in a meandering pattern, and that creates a localized upwelling and downwelling in the water column. And that upwelling and downwelling will provide oxygen to the developing eggs and elvin, as well as provide nutrients to the benthic macroinvertebrates. And here's the small army that helped me out with this. And that's me on the San Joaquin River in a kayak. Any questions?